Alright, so let's begin with our basic polynomial products. But before we Alright, so let's begin with our basic polynomial products. But before we do, let's start off with a very basic example. And let's just say that we're going to take two numbers and we're going to multiply 13 and 15. So the idea here is we multiply 5 times 3 and get our 15, and then we multiply 5 and 1 and add the 1, so we get 6, and then, let's use pink, and then we go over here and do 1 times 3 and write that down, and then we go back over here and let's use red, and we multiply the last two guys and we get a 1, and then we always do what? We add these, and then we come up with 195. So let's keep a note of this for a second, and let's play a little game. So what is 13? Well, 13 is a combination of two easy numbers, 10 and 3. And 15 is a combination of two easy numbers, 10 and 5. Now, the only reason I'm breaking them into tens is because they're easy to multiply. So if I use the same type of color scheme here, and I say, well, you know what, let's just use something we didn't use. Let's use this dark purple. So if we circle all of the terms, what that means including their signs, and then we try the same process by which we just did our multiplication, then this would be 5 times 3, or a positive 15. And then if we do our other way here, that would give us a 5 and a 10, so 5 times 10, well, that would give us 50. And let's see, we used pink last time, so 10 times 3, well, that's 30, but it's a positive 30, right? Just like the 50 is positive. And let's see, the 10 times 10 is 100. Again, it's positive. And then what do? Well, we add everything up again. So let me just move this over for a second because I want to make just a little more room so I can write this in to show you that we are doing nothing different than classic multiplication. So this would be 100 plus 80 plus 15, or 195. Now, it gets a little more interesting when we actually try something. So let's let 10 be equal to x. So in this case, we now have the expressions x plus 3 times the whole quantity x plus 5. And if we actually do this product, we can do it in the same mechanism. So let's just change all the 10s to x's. Oh, I put that there. Let's put this as a 3. And then times the x plus 5. And now let's just do our circles, just to remind ourselves that we're doing multiplication. And then I'm just going to use the same color this time. But this time, I'm going to go backwards, because as we can see, it doesn't matter. So x times x is x squared. And then we have x times positive 3, or plus 3x. And then we have, orange, positive 5 times x. So that's a positive 5x. And the last one would just be the 5 and the 3. They both have a new positive, so this is positive 15. And then what do? You simply add everything up. Well, this is just x squared plus 8x plus 15. And if you actually go back and you let x be 10, you can clearly see that what you get back is this BC here, and what we can clearly see back is that no matter how we slice it, we're still just doing what's called classic multiplication. And this works with any kind of polynomial that we're working with. So let's just try this out with a little bit larger of a number. Well, no, let's just do a very easy example. So example 1 real quick. Let's just do 2x minus 3 times the quantity, I don't know, x plus 3. So all we have to do is perform the general operations. So this would be 2x minus 3 times the quantity x plus 3. And if you do it all out again, you'll see that you're going to get 2x squared minus 3x plus 6x, and then minus 9. And then you do what? You add them. So you'll come up with 2x squared plus 3x minus 9. And you can check this multiple ways. Why don't you just let, I don't know, x to be equal to, let's say 1. And let's see what this would be. So this would be 2 times 1 minus 3 times the quantity 1 plus 3. And this would give us a value of, well, 2 minus 3, well, that says we have 2 positives and 3 negatives, so that means negative 1. And the next number that we have is clearly 4. So this looks like it breaks down to negative 4. So what we need to say is that this also gets us to where? Negative 4 if x is equal to 1. So let's just try this out real quick and evaluate this. This is called an evaluation. And what we can say is this 2 times 1 squared plus 3 times 1 minus 9. And what we're asking is this equal to negative 4? So this would be, well, 1 squared, that's 1. So this would be 2 times 1 plus 3 minus 9. And we're asking, is it equal to that? And then we have 2 plus 3 minus 9, and we're asking still, is it equal to this? And then we can see that this is 5 positives. I was multiplying there for a second. And then 5 positives and 9 negatives, so this does, in fact, equal negative 4. So let's try a little bit more of a difficult problem here. And try example 2 and set this up. So let's just set up x squared plus 2x plus 1, and let's multiply this all by x minus 3. So again, we can test this out to see how our classic multiplication works. This right here is just what we can think of as a 3-digit number. And right here, we could think of this as a 2-digit number. So what we're actually saying is like 111 times 12, or something to that effect. So if we do this out, we can just simply say x squared plus 2x plus 1 times the quantity x minus 3. And now, maybe I should go back and just remind ourselves how we look at this. And we just circle all of the terms. And now we perform the multiplication. So again, I'm going to start backwards, and I'm hoping you see why. But x times x squared is x cubed. And then we have x times a positive 2x, so that would be plus 2x squared. And then we have x times 1, or plus x. And now we have negative 3 times x squared. And I'm going to put that under the 2x squared because of the like terms. They both have x squares. So this would be negative 3x squared. And now let's use, what color should we use? Let's use gray, why not? And negative 3 times a positive 2, well, that gives us a negative 6x. And then we have our last piece, we'll use brown. We have the negative 3 times the positive 1, so this would give us a negative 3. And then all we have to do is combine all of these terms. So this looks like it gives us x cubed. We have more negatives than positives, so that looks like negative x squared minus 5x minus 3.